All right, let's talk about something that is often the secret villain behind those mysterious performance problems in your virtual environment. It's called NUMA, and, really understanding it is the key to unlocking some massive performance gains and maybe, just maybe, becoming the hero of your IT department.
So to really get this, let's kick things off with a scenario that is, well, it's the kind of thing that keeps IT pros up at night. Picture your most important database server just getting hammered, pushed to its absolute breaking point.
And this isn't some test in a lab. We are talking about a real-life 144-core production database server. It's brand new, it's running at full tilt, and it's completely crippled. I mean, how do you even begin to virtualize a beast like that without the whole thing just falling apart?
Well, because if you get it wrong, the consequences are pretty severe. In this exact case, just because the virtual setup was misaligned with the physical hardware, that machine took a staggering 55% performance hit. That's over half its power, just poof, gone.
So what's the culprit? What's behind this total catastrophe of a slowdown? Well, it all comes down to a really fundamental idea in how modern servers are built, and it's called NUMA.
NUMA stands for Non-Uniform Memory Access. The easiest way to think about it is like this. On a server's motherboard, each main processor, each CPU, has its own dedicated memory right next to it. Think of it as its own little neighborhood. But it can also reach across town to grab memory that belongs to the other CPUs.
Yeah, a NUMA node is basically that physical grouping of a CPU and its local memory, its own little block. Modern servers can have a bunch of these neighborhoods on a single motherboard, and each one has its own set of resources.
And that whole non-uniform part of the name, that's the part that really matters. When a CPU needs some data from its own local memory, from its own neighborhood, that access is lightning fast. But if it has to go on a road trip across the motherboard to get data from a remote neighborhood, that's where you pay a pretty big time penalty.
And here's the kicker. That trip to another neighborhood is more than 3 times slower. For a huge, performance-hungry database, like the one from our nightmare scenario, that kind of delay is an absolute performance killer.
Okay, so how do we fix this? Well, the very first step, believe it or not, is a little counterintuitive. Before you touch anything else, you have to make sure your virtual machine isn't just too big for its own good.
Now, what's really interesting here is what you're aiming for. The goal is to size your VM so its CPU usage peaks somewhere in that sweet spot, around 40 to 60%. This makes sure you've got plenty of horsepower when you need it, but you're not over-provisioning and wasting resources, which honestly just creates a whole different set of scheduling problems.
And this isn't just some theory, okay? In a real-world project looking at 2,700 production database servers, they found that a staggering 2,400 of them, that's almost 90%, were way oversized and could have easily run on just 4 CPUs or even less. Right-sizing them meant huge savings on software licenses and a serious performance boost.
All right, let's get to the next step. Once you've got your VM sized correctly, you've got to align it intelligently with the physical server hardware. This is where we get smart with what's called vNUMA, or virtual NUMA.
Honestly, the whole process is really just a simple matching game. First, you take a look at the physical layout of the server. How many processor sockets does it have? How many cores are in each one? Then, you figure out what your virtual machine actually needs. And finally, you just configure the VM to fit neatly inside those physical lines. The golden rule here is simple. Keep things local whenever you possibly can. So, for example, let's say your server has physical sockets with 12 cores each, and you need a 10-core VM. Well, you configure it as one single virtual unit. That way, the hypervisor, the software running your VMs, can just place that entire machine inside one physical NUMA node. And just like that, you've completely eliminated those slow, cross-neighborhood memory lookups.
But what happens if your VM is just too big to fit in one node? Let's say you need 16 cores, but your server has two 12-core physical sockets. You don't just throw 16 virtual CPUs in one big lump. No, you balance it. You configure the VM as 2 times virtual sockets with 8 cores each. This lets the hypervisor spread that workload evenly across both physical NUMA nodes.
Okay, so you've done all the hard work. You've right-sized your VM. You've aligned it perfectly. But how do you prove to everyone that it's running perfectly? Well, you look at 2 key metrics.
The first one is called CPU ready time. This number tells you, down to the millisecond, how long a virtual CPU is stuck waiting in line before it can actually run on a physical core. A super low ready time is your objective proof that your VMs aren't just sitting around waiting, and it proves the virtualization layer is not the bottleneck.
Now the second metric, and what a lot of people don't know about, is co-stop. This tends to happen with bigger VMs when one of its virtual CPUs gets way ahead of the others. To keep things from getting skewed, the hypervisor will literally hit the brakes on the fast vCPU, just to let the others catch up. Now look, tiny little blips in co-stop, that's totally normal. But if you start seeing high numbers that stay high, you've got a serious problem. It means your oversized or misconfigured VM is getting constantly paused by the system. And that can cause application freezes that last 20 or 30 seconds, or even worse, it can cause your users to get disconnected entirely.
So let's bring this all home. What actually happens when you take all this knowledge and you get vNUMA right? Well, you stop fighting fires and you start becoming the hero.
See, by properly sizing and aligning your VMs, you unlock these massive performance gains. You can save your company an absolute fortune on database licensing just by lowering the core counts. And you can safely pile more workloads onto the same hardware because everything is just running so much more efficiently.
And you know, sometimes the fix is ridiculously simple. For apps like SQL Server, a database admin can just tweak a single setting. It's called max degree of parallelism to match the number of cores in a physical NUMA node. Just making that one simple change, aligning the software with the hardware, can give you a 25 to 50% performance boost, just like that. So by really understanding and mastering vNUMA, you're not just a server admin anymore. You're directly providing incredible business value. You're making the applications faster, you're saving the company serious money, and you're becoming that go-to expert. And that, right there, is the power of demystifying vNUMA.